First, let's go through some basics of the electronic items which will be used to operate the stepper motor. So this is an Arduino board. It's a microcontroller which can take input from various sensors like ultrasonic sensor, thermal sensor, light sensor, and then it will process these inputs according to our code. Then it can write outputs to these pins which will be used to operate other things like stepper motor, servo motor, LEDs, etc. Now it has got 13 digital pins whose values can be set either 0 or 1. It has got some power pins, two ground pins and a 5-volt pin and a 3.3 volt pin, and this is the port which will be used to connect this board to the PC. This is a 6-pin stepper motor which looks something like this from inside. It has two coils which has turns alternate to each other, A, B, A, B. Now this has 6 pins because each coil will give us 3 wires to the outside, 2 from its ends and 1 from its center. This is the stepper motor driver. It helps the communication between the Arduino and the stepper motor. It has got a screw on the top which helps in adjusting the current in the stepper motor. It has got 16 pins. Each pin can have value 0 or 1 except the voltage pins. The direction pin sets the direction of movement of our stepper motor. For the step pin, the value is set to 1 and then to 0. This cycle will move our stepper motor by one step. By repeating this cycle n times, we can move our stepper motor by n steps. Then there are reset and sleep pins. After that there are MS1, MS2, MS3 pins. These are used to increase the resolution of the movement of our motor. We can break down one step of the motor up to 16 steps by adjusting the value of these 3 pins according to this table. Then these ground and VDD are connected to the ground and VDD of the Arduino. The lower ground and V-mode are connected to the plus and minus of the power supply. Here 1A and 1B should be connected to coil 1 and 2A and 2B should be connected to coil B. If we mix those up, the motor will not move, it will just vibrate. Let's identify the ends of the same coil for this 6-pin stepper motor. So this connector comes with the stepper motor. We connect it to the motor. It has 4 wires and each coil have 2 ends. So let's identify those. First we connect these two jumper pins so that we can identify the voltage and thing. Now we have 4 ends and we have to identify which of these two belongs to the same coil. So we have this multimeter. We will measure the resistance of the coil. As you can see, when the ends are open, it doesn't show any reading. There is one. So if these two ends belongs to the same coil, that means they are connected inside this stepper motor, and these will have some finite value of the resistance. So let's check. And as we can see some finite value, this means that these two ends belongs to the same coil. When I connect this end to one of those wires, it will not show any reading because these two do not belong to the same coil. So we have identified that these two belong to the same coil and so these two do. See, so make sure that these two are connected to 1A and 1B of the motor driver, and these two are connected to 2A, 2B of the connector.
Do not mix up like this, otherwise the motor will just vibrate and will not move.
Let's go through the connections for our circuit between stepper motor, the driver, Arduino and our power supply. So we have identified the two ends of the same coil and we will connect accordingly 1A 1B to the first and to the first coil, 2A 2B to the second coil. We will connect ground and VMOD to the power supply and ground and VOD to the Arduino ground and 5-volt pin. Then we will connect the direction pin to the 6th digital pin and step pin to the 7th one. We will keep in mind the pin number so that we can use them later in our code. We will connect the sleep and reset pin to each other. Then MS123 to the pin number 11, 12 and 13 of our Arduino board. You can connect to any pin number. We just have to take care that we put the same pin number in our code.
We have this Arduino board, these are digital pins, and these are here 5-volt ground pins and some analog pins. Okay, this is the stepper motor driver A4988 which we were talking about. This is the current limiting screw right here, and this is a breadboard. We will use this one to make our connections, this one and these jumper wires. Now we will go through one by one. First, let's connect our stepper motor. So these are the four wires from our stepper motor. So let's connect. We have two pins left at this side and two left at this side. These are the pins, ground and V mode pin that we have connect to Arduino, and these are the one which we have to connect to the power supply. Let's connect the power supply first. So these are the pins from power supply. This red one is plus and the black one is minus. So let's connect these here. This one line is all connected. So if I put the one pin here and second pin here, these two will be connected. So now let's connect this red pin with the V mode of our motor driver, which is the uppermost pin, this one, to the ground pin. So the lowermost, this white one, is the ground pin and this one will be the voltage pin. Let's connect ground pin to the ground pin and voltage to the 5-volt pin. Let's come to this side. The uppermost is the enable pin. We don't have to connect it to anyone. Now there are MS1, 2 and 3, so we'll connect them to 11, 12 and 13 of this pin. The uppermost is MS1, this white one. We'll connect it to 11, then 12 and then 13. Then there is reset and sleep pin. We will connect those two together. Then there are step and direction pin. Lowermost is the direction pin and we will connect the direction pin to number 6. Let's connect this Arduino board to our computer and then we will limit our current.
This is the same connection in as was in the previous diagram. Take a multimeter, set it so that we have to measure the voltage between 2 points, and these are the 2 points, the screw and the ground which was connected to the Arduino board. Using this formula V equal to current limit divided by 2.5, we will calculate what should be the voltage difference between these 2 points. This 2.5 factor comes from the various resistances used in our driver. So in our case, we are using NEMA 17, which has a current limit of 0.75 ampere, which gives us the voltage value as 0.3.
As we saw, let's set our measuring thing to voltage. We have to measure the voltage between this screw and this first pin. So put one end on this screw and then on this first pin, and we see it's 0.31. Well, I had set it earlier. If this is not set, you can use this screwdriver. Keep one thing in mind, that if the current value is higher, your stepper motor will start heating after some time. After some time you check your stepper motor. If it's heating, you have to reduce your current value. Let's install the Arduino IDE through which we will give our code to Arduino. Go to this website sport.arduino.cc and download the Arduino IDE for the Windows. So an application file will be downloaded. You double click on it to install this file. After the installation, you run this IDE and you will see this kind of interface.
First, we have to set some variable names for our pins. So constant integer, or first we'll set for the direction pin, which is connected to pin number 6. Then for our step pin, which is connected to pin number 7. We will see about MS123 later. In the setup thing, we have to set the initial things, like the direction pin is an output pin. We will write to the direction pin. For that, we have to set which pin mode is this. This pin mode for our direction pin is output. If it was taking input, we would have put the input. Pin mode for step pin, it's also output. Now void loop, this thing will keep on running. We have to put the code which we want to run endlessly into this thing. So what we will do, we will set our direction pin. To write to a pin, we use digital write to write to a digital pin, and we have connected to digital pins only. So digital write, which pin? The direction pin. What we will write? High means 1, which will set some direction to our stepper motor. If we will put low, then the direction will be opposite. Now for the step pin, we, as discussed earlier, setting the pin to high and then after some time to low will move our stepper motor by one step. So we will use a for loop to, at the end of every line we have to put this semicolon. For, let's say we have a variable x which is initially 0, integer x which is initially 0. Now will move our motor by 2000 steps. So when x is less than 2000, and in each step we will increment the value by 1 step in too high. After this, as the processor is very fast, we have to give it some delay so that this pulse of high current can reach the coils of our stepper motor. So we will make a delay using this function delay microseconds. How much microseconds we will? Let's say 1000. We can set this value higher or lower according to the speed we want in our motor. Now we will do the similar thing, just write it as low and give the similar delay. So this is the most basic code to run a stepper motor. We will upload this. Okay, we have to write give semicolon after every line. Go to the tool board, you select your Arduino UNO board. port, you select whichever port your Arduino board is connected to, and then simply upload this code. Now set our MS123 pins to have some micro stepping. So let's go to the highest resolution. Now if we upload the code without changing the step and delay, still our motor speed will be very low because the rotation it was having in one step earlier, now it will take 16 steps to for the same movement. Now this is the code for moving two stepper motors at variable speeds. We will upload this and see the output.